Hello guys, this is just me, Mr. Wee. I'm here just to go over a few things today. We're going to start by going over 9-3 today with the section with similar triangles. But before we do that, let's go ahead and do a quick warm-up really quick. So after I write down the question here, I want you and a partner to solve this for the next few minutes or at home just by yourself, however you want at your pace. Okay, so let me draw two shapes that look two quadrilaterals that look similar, not necessarily insinuating that they are similar. Okay, so we have two quadrilaterals which I can confirm, even though they're poorly drawn, that the angle in the upper left-hand corners of these two quadrilaterals have the same angle measure in the upper left-hand corner as well as the upper right-hand corners, as well as the lower right-hand or lower left-hand corners, as well as 1, 2, 3, 4 dashes, 1, 2, 3, 4 dashes, 1, 2, 3. So all the angle measures in the same order are the same in both of these products here, or both of these shapes here. And then the side lengths are 15, 5, 12, and 4, 7, 21, and 6, and 18. Okay, this is 18. I want you to determine if these two shapes are similar or not. So go ahead and pause really quick and prove to me with a partner or by yourself, prove to me that these are going to be similar or not. So go ahead and pause, and then when you're ready, unpause this video to see the answer. Okay. All right. Well, hopefully you're unpausing the video now to see what the answer was. So overall, these should have been yes, or the answer to the question should have been yes, that they are similar. And the question is whether you understand the concept of similarity or not. So just to reiterate, similar does not necessarily mean that they're congruent. If these two shapes were congruent, not only would the angle measures be the same, but the side lengths should be exactly the same. But however, they're not. But a good thing is, if you have two objects that have similar angles, you will end up with a structure that should be similar. So these side lengths were carefully picked. These were not randomly generated. So in order to check that to see if that works, if two shapes have exact same angle measures, their side lengths should be not be the same, but they should be proportional. So I know that this top length here should be proportional to this top here from these two quadrilaterals. So let's see, 15 divided by 5, and then let's see if that's proportional to the ratio of these sides on the right hand sides, 12 and 4, only because we notice that the order of the angles is the same, where there's a 2 dash and a 3 dash in the upper right to lower right hand corner. In the same way, this quadrilateral has the angle measure that is the same in the upper right hand corner than the lower right hand corner in the same order, the 2 dash and the 4 dash. Okay, so you have to kind of go by the same order of angles to indicate which sides are going to be form a proper ratio to each other. So this ratio of 15 to 5 should be proportional to this ratio of 12 and 4. And then this ratio on the bottom of 21 and 7 should be equal as well to these ratios of 12 to 4 and 15 and 5. Okay, and the last one is 16 and 8 equals 16 or 18 divided by 16. Notice that the order goes from, I chose to go the bigger quadrilateral to the smaller quadrilateral, and I kept that order consistent. I always go from the corresponding sides, first going in the order from the bigger quadrilateral on the top to the smaller. If I choose to do that, I have to keep doing in that order consistently to ensure that these ratios are proportional to each other. If I started with the smaller side up here first, 5 to 15, then the rest of the ratios I have to do it in the same way in the order to ensure that they're equally judged in proportionality in that way. So let's see, 15 divided by 5 is equivalent, or if you can simplify it down to 3 over 1, 12 over 4, if we can factor out a common factor from both of these, the greatest common factor in 12 and 4, which would just be 4, I would know that this simplifies down to 3 over 1. And then over here, the greatest common factor between 21 and 7 is 7. So if I divided by 21 by 7, 7 divided by 7, I would know it with 3 over 1. And then over here, the greatest common factor would be 6. So if I divided the top number by 6 and the lower bottom number by 6, I would get 3 over 1. Again, all the corresponding sides forming a ratio, form proportional ratios, or the same ratios. So that tells us that yes, both of our items are similar. Okay, so welcome guys. This is going to be just a warm up into talking about what similarity is. This should have been from 9.1, 9.2. I'm going to do this in parts, so that was just a warm up. So I just want to welcome you guys back. And then in the next video, we're going to start with brand new material. Okay, all right, thank you for joining me, and welcome back. Our next video. I'm able to stop this video. Let's see. Up.